SLAC National Accelerator Laboratory, originally named Stanford Linear Accelerator Center, is a United States Department of Energy national laboratory operated by Stanford University under the programmatic direction of the U.S. Department of Energy Office of Science and located in Menlo Park, California. The SLAC research program centers on experimental and theoretical research in elementary particle physics using electron beams and a broad program of research in atomic and solid-state physics, chemistry, biology, and medicine using synchrotron radiation. History: founded in 1962 as the Stanford Linear Accelerator Center, the facility is located on 426 acres of Stanford University-owned land on Sand Hill Road in Menlo Park, California, just west of the university's main campus. The main accelerator is 2 miles long, the longest linear accelerator in the world, and has been operational since 1966. Research at SLAC has produced 3 Nobel Prizes in Physics. 1976, the charm quark, CJ, Psi meson. 1990, quark structure inside protons and neutrons. 1995, the tau lepton. SLAC's meeting facilities also provided a venue for the Homebrew Computer Club and other pioneers of the home computer revolution of the late 1970s and early 1980s. In 1984, the laboratory was named an ASME National Historic Engineering Landmark and an IEEE milestone. SLAC developed and, in December 1991, began hosting the first World Wide Web server outside of Europe. In the early to mid-1990s, the Stanford Linear Collider investigated the properties of the Z boson using the Stanford Large Detector. As of 2005, SLAC employs over 1,000 people, some 150 of which are physicists with doctorate degrees, and serves over 3,000 visiting researchers yearly, operating particle accelerators for high-energy physics and the Stanford Synchrotron Radiation Laboratory for synchrotron light radiation research, which was indispensable in the research leading to the 2006 Nobel Prize in Chemistry awarded to Stanford professor Roger D. Kornberg. In October 2008, the Department of Energy announced that the center's name would be changed to SLAC National Accelerator Laboratory. The reasons given include a better representation of the new direction of the lab and the ability to trademark the laboratory's name. Stanford University had legally opposed the Department of Energy's attempt to trademark Stanford Linear Accelerator Center. In March 2009, it was announced that the SLAC National Accelerator Laboratory was to receive $68.3 million in Recovery Act funding to be disbursed by Department of Energy's Office of Science. Components: accelerator. The main accelerator is an RF linear accelerator that can accelerate electrons and positrons up to 50 GeV. At 2.0 miles long, the accelerator is the longest linear accelerator in the world, and is claimed to be the world's most straight object. The main accelerator is buried 30 feet below ground and passes underneath Interstate Highway 280. The above-ground Klystron Gallery atop the beamline is the longest building in the United States. Stanford Linear Collider. The Stanford Linear Collider was a linear accelerator that collided electrons and positrons at SLAC. The center of mass energy was about 90 GeV, equal to the mass of the Z boson, which the accelerator was designed to study. Grad student Barrett D. Millikan discovered the first Z event on 12 April 1989 while poring over the previous day's computer data from the Mark II detector. The bulk of the data was collected by the Sla See Large Detector, which came online in 1991, although largely overshadowed by the Large Electron-Positron Collider at CERN, which began running in 1989. The highly polarized electron beam at SLC made certain unique measurements possible, such as parity violation in Z boson B quark coupling. Presently no beam enters the south and north arcs in the machine, which leads to the final focus. Therefore this section is mothballed to run beam into the PEP2 section from the beam switch yard. Sla See Large Detector. The Sla See Large Detector was the main detector for the Stanford Linear Collider. It was designed primarily to detect Z bosons produced by the accelerator's electron-positron collisions. The SLD operated from 1992 to 1998. PEP began operation in 1980, with center of mass energies up to 29 GeV. At its apex, PEP had 5 large particle detectors in operation, as well as a 6th smaller detector. About 300 researchers made use of PEP. PEP stopped operating in 1990, and PEP2 began construction in 1994. PEP2 from 1999 to 2008. The main purpose of the linear accelerator was to inject electrons and positrons into the PEP2 accelerator, an electron-positron collider with a pair of storage rings 1.4 miles in circumference. PEP2 was host to the Bar experiment, one of the so-called B-factory experiments studying charge parity symmetry. Stanford's synchrotron radiation light source. The Stanford Synchrotron radiation light source is a synchrotron light user facility located on the SLAC campus. Originally built for particle physics, it was used in experiments where the J-psi meson was discovered. It is now used exclusively for materials science and biology experiments which take advantage of the high-intensity synchrotron radiation emitted by the stored electron beam to study the structure of molecules. In the early 1990s, an independent electron injector was built for this storage ring, allowing it to operate independently of the main linear accelerator. Fermi Gamma-Ray Space Telescope. SLAC plays a primary role in the mission and operation of the Fermi Gamma-Ray Space Telescope, launched in August 2008. The principal scientific objectives of this mission are to understand the mechanisms of particle acceleration in AGNs, pulsars, and SNRs, to resolve the gamma-ray sky, unidentified sources and diffuse emission, to determine the high-energy behavior of gamma-ray bursts and transients, to probe dark matter and fundamental physics. KIPAC. The Kavli Institute for Particle Astrophysics and Cosmology is partially housed on the grounds of SLAC, in addition to its presence on the main Stanford campus. PULSE. The Stanford Pulse Institute is a Stanford independent laboratory located in the Central Laboratory at SLAC. PULSE was created by Stanford in 2005 to help Stanford faculty and SLAC scientists develop ultra-fast X-ray research at LCLS. PULSE research publications can be viewed here. LCLS. The LINAC Coherent Light Source is a free electron laser facility located at SLAC. The LCLS is partially a reconstruction of the last one-third of the original linear accelerator at SLAC, and can deliver extremely intense X-ray radiation for research in a number of areas. It achieved first lasing in April 2009. The laser produces hard X-rays, 109 times the relative brightness of traditional synchrotron sources, and is the most powerful X-ray source in the world. LCLS enables a variety of new experiments and provides enhancements for existing experimental methods. Often, X-rays are used to take snapshots of objects on the nearly atomic level before obliterating samples. The laser's wavelength, ranging from 200 to 2000 electron volts, is similar to the width of an atom, providing extremely detailed images for objects previously unattainable. Additionally, the laser is capable of capturing images with a shutter speed measured in femtoseconds, or million billionths of a second, necessary because the intensity of the beam is often high enough so that the sample explodes on the femtosecond timescale. LCLS-2. The LCLS-2 project is to provide a major upgrade to LCLS by adding 2 new X-ray laser beams. The new system will utilize the 500 meters of existing tunnel to add new superconducting accelerator at 4 GeV and 2 undulators. The advancement from the discoveries using this new capabilities may include new drugs, next-generation computers, and new materials. Facet in 2012, the first two-thirds of the original SLAC LINAC were recommissioned for a new user facility, the Facility for Advanced Accelerator Experimental Tests. This new facility is capable of delivering 23 GeV, 3 nanocoulomb electron beams with short bunch lengths and small spot sizes, ideal for beam-driven plasma acceleration studies. NLCTA. The next linear collider test accelerator is a 60 to 120 MeV high-brightness electron beam linear accelerator used for experiments on advanced beam manipulation and acceleration techniques. It is located at SLAC's End Station B. A list of relevant research publications can be viewed here. Other discoveries. SLAC has also been instrumental in the development of the klystron, a high-power microwave amplification tube. There is active research on plasma acceleration with recent successes such as the doubling of the energy of 42 GeV electrons in a meter-scale accelerator. There was a paleoparadoxia found at the SLAC site, and its skeleton can be seen at a small museum there in the breezeway. The SSRL facility was used to reveal hidden text in the Archimedes palimpsest. X-rays from the synchrotron radiation light source caused the iron in the original ink to glow, allowing the researchers to photograph the original document that a Christian monk had scrubbed off.